Welcome to this online session, and today we are going to discuss on the topic of electromagnetic induction. So electromagnetic induction is nothing but production of electromotive force, that is EMF. So it is the voltage across the electrical conductor with the changing of magnetic field. So a famous scientist, Michael Faraday, he discovered this induction in the year 1831. And today we are going to see some interesting facts behind this topic, electromagnetic induction. Let us move on to the presentation. So before electromagnetic induction, we have to know what is magnetic flux. So the number of magnetic lines of force crossing a surface normally is called the magnetic flux linked with the surface. If the normal which is drawn to the surface area A makes angle theta with a magnetic field B vector, then the magnetic flux will be phi equal to BA cos theta, which is B vector into A vector. Therefore, the magnetic flux is a scalar quantity and the dimensions of the magnetic flux is M, L2, A minus 1, T2. So here comes electromagnetic induction. So it is the phenomena of production of induced EMF and hence the induced current. So it is due to the change of magnetic flux linked with the closed circuit. The term electromagnetic induction means inducing electricity by the magnetism. So from the image you can see how the electromagnetic induction is working. And Faraday's law of electromagnetic induction. So Michael Faraday gave two laws. First law is whenever the magnetic flux linked with the closed circuit changes, an EMF is induced in it, which lasts only so long as the change in flux is taking place. So this is first law. And the second law, he says the magnitude of the induced EMF is equal to the rate of change of magnetic flux which is linked with the closed circuit. So the second law is represented mathematically as summation, that is E, summation also we can say. It is the induced EMF is equal to d phi by dt. Here comes the Fleming's right hand rule. So it gives the direction of the induced EMF. If we stretch the thumb finger, then and next two fingers, that is the first two fingers of our right hand mutually perpendicular to each other, and if the forefinger points the direction of the magnetic field and the thumb finger gives the direction of the motion of the conductor and the central finger points the direction of the current induced in the conductor. This is the Fleming's right hand rule. And here comes the methods of generating the induced EMF. What are the methods to generate this induced EMF? So as phi equal to BA cos theta, so the magnetic flux which is linked with the loop can be changed and hence the induced EMF can be produced by three methods. So first one is by changing the magnetic field B. Second one by changing the area A of the loop. And third one by changing the relative orientation of the loop and the magnetic field. These are the three methods we can use to generate the induced EMF. And here comes eddy current. Have you heard this word eddy current? So this is the current induced in a solid metallic masses when the magnetic flux threading through them changes. So such currents will flow in the form of irregularly shaped loops throughout the body of the metal and their direction is given by Lenz's law. So eddy currents causes the unnecessary heating and wastage of the power. So that can be rectified or that can be reduced by using the laminated soft iron cores. So the useful, that is the uses of this eddy current is, it is used in electric brakes, it is used in speedometers, and it is used in induction furnaces, and it also used in electromagnetic shielding. So here comes self-induction. If the phenomena of the production of induced EMF in a coil when a changing current is passing through it means it is self-induction. So, the production of induced EMF in a coil when changing current when it is passing through it, it is self-induction. And what is mutual induction then? So, that self-mutual it means it is two. So, the phenomena of production of induced EMF in one coil when the current through the neighboring coil changes at the unit rate. So, this is the mutual induction. And here comes the coefficient of coupling. So, it gives the measure of a manner in which two coils are coupled together if that is L1 and L2 be the self-inductance of the two coils and M be the mutual inductance of the coil. So, then the coefficient of the coupling will be, so K is the constant for this coefficient of coupling, which is equal to root of M divided by L1 into L2. And the value of K will lies between 0 and 1. So, this is about the coefficient of coupling. Thank you.